Well, hello everyone, and welcome to Prep 7. So in this prep, we're going to be looking at probabilities. And we're going to start here with an example. So here we have a salary distribution, and we have the salaries for all 100 employees of a business listed below. The salaries are organized by employee number, and they're also arranged or sorted from lowest salary to highest salary. In addition to that, we've color-coded different groups of salaries. Those color codings are designed to match this histogram over here, which we'll talk about in a second. So first we're going to begin by answering some questions from the raw data. What percent of employees earn $39,601 or less? So let's find $39,601, which is here. That's with employee 16, so that's 16 employees out of 100. That should be 16%. What percent of employees earned $48,276 or less? So let's find that number down here, which is right there. That's employee 50, so it's going to be 50%. And what percent of employees earn more than $59,508? So let's find $59,508. That's this number here. That's employee 84. So we've got from employee 84 to 100, that's 16 employees, so that will be another 16%. All right, now the next job is to make this histogram. And in order to make a histogram, what you need to do is tell it which data you're going to be working with. So here we're going to be working with the salary data. So I'm going to highlight the whole salary column. And then go to the Insert menu. And we'll pick our recommended chart looking for the histogram. And there it is. And then, oops, I moved the wrong thing. Let me grab my histogram and drag it up to where we actually need to place it, because remember the top left corner of the histogram has to fit pretty close to that top yellow square. It doesn't have to be exact, but it has to be pretty close. All right, and then to make my histogram look just like this one, I need to look at this. This one has 6 bars. I have 7, and so I can change that. On a Mac, I would click on the data series. On Windows, you would actually click on the axis, and then we'll go to Format. And so for the number of bins, I'm actually going to do it by number. Pick 7 bins. Let's see if that gives me what I want. Oh, sorry, I didn't mean 7. I meant 6. I had 7. And that looks like it now matches. So I'm good to go. That's the only change that I need to make, other than giving it a title. Salary distribution. All right, now, don't worry about these colors not matching. I mean, you can actually change them. You know, if you click on a series and then right-click on it again, you can come over here and you can, using the fill, change the color. But don't worry about that. You don't have to do it. All right, so let's go ahead and answer from the histogram. What percent of employees earned 42,022 or less? All right, so here's 42,022. So it's everyone that fits in these first 2 boxes of the histogram. And in the first box, actually, just to show you, there's 8 employees here, right? And they would be stacked vertically, but they didn't all fit, so without it being too small. So there's 8 in here, there'd be 8 in here, so 8 and 8 is 16. So 16 out of 100. What percent of employees earn more than 57,000? That's here. This one's a little harder to count. So we've got, it looks like 13 here in this one, and then another 4 in this one, so that would be 17%. All right, now we're going to do some descriptive statistics. So we want the mean for the average of all these guys. and then we want the standard deviation. And there's two forms of standard deviation. We're going to use the .p, which stands for population form, because these are all the employees, not just some of them. And there's our standard deviation. So it's about, not quite, but it's about 50,000 for the mean and about 10,000 for the standard deviation. All right, now we're going to look at what's sometimes called the 68, 95, 99.7 rule, or we actually typically refer to it as the empirical rule. You'll hear it called both things. And it's a great rule of thumb that highlights the importance of the standard deviation, because if you know this rule and you know the standard deviation, you can actually predict how many observations fall in certain boundaries. And this thing actually is, I know it looks like a smooth curve, but imagine it as a bunch of really narrow bars of a histogram, because that's kind of what it's supposed to be. All right, so let's look at the mean, which is that. And then we're going to subtract one standard deviation here. So it's going to equal to that number minus standard deviation. And then over here, we'll take that number minus 2 times the standard deviation, subtracting 2 standard deviations. And then on the other side, adding standard deviations. First one, and then adding a second one to the mean. All right, now we can actually use that empirical rule to answer some questions here. So I'm going to skip this for just a second so that you can see this. Approximately what percent of employees earn between 39,871 and 60? There's 39,871, there's 60. So that's one standard deviation either side. The empirical rule tells us that one standard deviation at either side, this way to this way, is going to be 68%. So that ends up being 68%. Approximately what percent of employees earn between 49,953 and 60? There's 49,953, there's 60. So it's basically from here to the first standard deviation. Well, that's a little tricky, right? We know the whole thing is 68, so it's basically half of that, or 34. All right. Now let's come back to this. We want to see if our data actually matches the empirical rule. In other words, if this data really follows this. We assumed it here, but let's see if it's true. So we're going to use the countifs function, and our criteria range for the countifs is going to be these values here. And I'm going to lock that range just to make it easier to get the second one. And then I want to be greater than or equal to the lower bound, which is that number. And then I want the same range. In fact, I'm going to lock that too. And then I want the same range which will also lock to be less than or equal to the upper bound, which is that. So that's one standard deviation either side, because that's what we want here. And I'll lock that too. And I get 68. So that's great, because 68 out of 100 is about 68%, which is exactly what this is telling me I should find. All right, now let's copy that and then change it for the 2 standard deviations. So I'll click on this, and I'll show you a little pro trick. Like if this is pointing to the wrong thing, you can grab the edge of it and scoot it to where it goes. If that didn't work for you, like if you end up moving the cell, that's bad, undo. And you can always, just do it the regular way. Okay, so 68 and 96. And then finally down here, the last thing we have to do for points on this page, and what we will be doing for most of the rest of the course, is using the norm.s.distribution function. And so this allows you to get a very precise calculation. So what percent of employees earn less than or equal to 1 standard deviation above the mean? So we say that equals norm.s.dist. And as soon as we open the parentheses, it'll tell us that it's looking for a z-score. Well, z-scores are actually just counting standard deviations. So if I say 1 standard deviation above the mean, I mean a z-score of 1. And then the second argument is either going to be true or false. And for our entire course, it's going to be true because we want the cumulative distribution. It means everyone to the left of me going all the way up to me. And that's 84%. And that's it for the first video.